Today, I am presenting my project titled as Automated Deadlock Detection Tool. This project focuses on detecting and analyzing deadlocks in operating systems using core concepts like resource allocation graphs, cycle detection, and Banker's algorithm. The goal of the system is to help users identify deadlocks, understand system states, and get resolution solution in a simple and interactive way. So, in operating system, deadlock occurs when processes are stuck waiting for resources held by each other, forming a circular waiting condition. Detecting deadlocks manually is very complex, especially in systems with multiple processes and resources. So this project solves that problem by automatically analyzing the process resources relationship, detecting circular dependencies, providing safe unsafe state analysis, and suggesting prevention and recovery strategies. So the project is divided into two main parts, which is front end and back end. So the backend is made up of Python and Flask, which basically does the functions the, of detection engine, which controls the entire detection flow. Banker's algorithm, which checks the system safety. Cycle detection, which finds the circular weights. Rack builder, which builds the resources and allocation graphs. And validator and parser, which ensures the correct input. We also implemented resolution modules which suggest prevention and recovery, report generator which creates PDF reports, and logging system which tracks the execution, and the front end part which consists of HTML, CSS, and JavaScript. The front end provides a clean two-column UI. The left side contains of system configuration which consists of resources and processes, and the right side is the detection result which basically shows the graphs and the result which are formed. The features included are dynamic input and processes and resources, which is basically this the load sample, multi-select drop downs, real-time validation, graph visualization, stimulation steps. So now let me demonstrate how the system works. First, we need to define the processes and resources. So basically this is the resource R1, this is the resource R2. These two are the processes P1 and P2. R1 is allocated to P1, R2 is allocated to P2, and P1 requests R2 and P2 requests R1. So each process has allocated resource and requests some resources. When I click on the run detection, the backend processes the input. The system builds a resource allocation graph. Uh, so this, the first one is the cycle detection part, which detects if the cycle is there or not, and one cycle is there. And the banker's algorithm, which is working in the backend, if it's safe and unsafe. This is showing here, and the output shows basically the deadlock status, which if the deadlock is detected or not detected, and involved processes. This simulation. These are the involved processes, and graph nodes and edges. Basically, which is this is the graphs which consist of nodes P1, P2, R2, and R. It also provides prevention suggestions and recovery strategies. Additionally, users can view graph visualizations, run step-by-step simulations, next, which takes you to the next step, and just like this, you can navigate through the different steps and download a PDF report, which is basically this. So the key features are combination of Banker's algorithm and cycle detection, the resource allocation graph, and step-by-step simulations, as well as the additional resources are the PDF report generation, real-time validation, and clean and responsive UI, as you can clearly see. So, in conclusion, this project provides a complete solution for deadlock detection and analysis. It not only detects the deadlock but also helps users to understand system behavior and possible solutions. Thank you for watching.